I am Sukriti Arora from Board of Studies.
I am Alok Gupta from Board of Studies.
And we welcome you all on today's online mentoring session on the topic Telecommunication Networks and Flowcharts. In this presentation, we will mainly be talking about the basic concepts of telecommunication, the transmission media, the topology, the network security, how do the transmission take place from one node to another. So we would be asking some of the queries. If you will be having any during the session, you are most welcome to post the queries online. But before we start the presentation, we would just like to have a look at the disclaimer. Kindly take a note of the disclaimer. These lectures are freely available online. A student just needs to register with his registration number. Before starting the session, we would just like to give you some of the introduction regarding the ITT syllabus.
In ITT syllabus, we have two modules, Module 1 and Module 2. In Module 1, we will cover the topic Computer Fundamental. In Computer Fundamental, we will teach the topic, it's the basics of computer. Next is the computer hardware, including an input-output device, secondary storage, primary storage, auxiliary storage, CPU, etc. Next part is the mobile hardware and networking concept. Second chapter is the operating system. In operating system, we'll teach it's a fundamental of the basic operating system, then multi-programming, multi-threading, multi-processing, multitasking, and time-sharing system. Next, overview of the latest Windows operating system. Third chapter is the office automation, in which we cover Microsoft Word, Excel, and PowerPoint practically. In Module 2, again we have a 3 chapter. It's a database. In database, we have 2 parts, database theory and practical part is the MS Access. In a database theory, fundamental of database theoretical part we'll discuss here. In MS Access, we'll discuss the practical part of the database. MS Office Utility and Software for CA accounting. Software for CA. Office Utility, we have a 2 package. It's a Outlook and MS Calendar. And Software for CA, we will cover the topic. It's a packages provided by the IC. It's a eSecretary, KDoc, etc. Third chapter is a accounting package. It's a tally.erp9. And next one is the web technology, in which we will cover all the internet related topics.
Now during the ITT training, the students get a fair idea of the fundamentals, the MS Access database, and the accounting packages. Taking that particular knowledge further, we go for IPCC examination, wherein the most likely question that students ask is, which is the edition applicable for November 2016 examination. So for the coming examination, July 2015 edition or any reprint of it, the study material and practice manual are going to be applicable. The RTP for November 2016 examination, that will be available shortly, that you will be referring for your examination. And then the mock test papers, as and when they will be published, you will be taking those examinations and will be reviewing your concepts through the mock test papers. Compilation, the July 2015 edition, and suggested answers till May 2016 examination. Now, what generally the pattern of question paper is? The question paper generally has 7 questions, out of which the first question stands compulsory. That first question is of 10 marks and it may have 5 subparts, 2 marks for each subpart. Out of the remaining 6 questions, an examinee is supposed to attempt any 5 questions, and in these 5 questions, 1 question may also carry an internal choice. Now generally the question is asked that how do we prepare for the examination to get the good marks, or how do we write the paper in examination so that the students pass the examination with good marks. So by and large, we firstly need to understand that the IT is a technical paper and there cannot be any shortcut of it. So one needs to understand that he or she has to know the syllabus and the expected level of knowledge. You have to have a detailed study plan and you have to allocate the time for each of the topic of the subject. That means it is suggestible that you should be studying this particular subject every day at least for 2 hours. It cannot be a possibility that you are studying one chapter in one go or one subject in one go and leaving the IT paper for the last moment. Reason being, this is a paper which you are not in touch with on your day-to-day basis. So it is better that you study this subject every day, maybe for some duration, and slowly and steadily you will gather some kind of confidence in the subject so that you will be able to move further. And once you have understood the concepts, then you should try to go for the practice manual. The questions that are available there, you should practice those answers by thoroughly writing them. It cannot be just mugging up and just remembering those points. You need to know how to write the answers. So you write the answers and go back to the practice manual to cross-check, have you understood the topic clearly or not? That will be self-introspection, and this way you will be able to understand which particular area you need to concentrate more on. So you have to read each chapter of the study material thoroughly for conceptual clarity. Some students may gain the clarity in 2 readings, some may take even 4 readings. But just for the sake of reading, don't read. Whenever you are reading, you have to apply your mind while understanding what the concept is all about, and that may take 3 to 4 times reading. Then once you have understood the concepts, then you need to practice those questions through the practice manual, and you have to repeat this process for each and every chapter. Chapter wise you will be picking up, you will be doing the reading, you will be understanding the concepts, and then this way you will be doing it for each and every chapter. And after completing study of all the chapters, then RTP will come in picture. You have to take up the RTP. That RTP contains the questions either topic wise or chapter wise. So once you are thoroughly done with the subject, study material and practice manual, then you should try to go for the RTP and you try to attempt those questions. And yes, again and again I would emphasize that please do write the answers, because if you will be writing the answers, you will come to know which particular area you are lacking in, so that the type of mistakes you are making at home, you should not be making them directly in the examination hall. So first reading is to gain the overview, second reading is the in-depth study, and then the third reading will include the intensive reading to fully understand the concept and to underline the important points to be revised on the examination day. Now we shall start with the topic telecommunication networks. What is a computer network? So a computer network is a collection of autonomous means independent computers. That means they are the independent computers, they will not be having any contact with each other. So they are my PC, it can be a laptop at home, it can be a system in an office, it can be a phone server. So these are all independent devices and we need to communicate amongst each other, so they need to be interconnected. And when we say the interconnection, so interconnection has to be through some means, and for that you have to have a media through which the telecommunication or the data transmission will take place. And why do we need to interconnect? Because we end of the day want to share some type of resources like audios, videos, doc files, storage servers, etc. and provide high reliability. What does this mean? This means that supposedly there is a file which is available on system X and I want to keep a replica of it. So it is better that if I share it with any other system, say Y, so I will be having the file available at X as well as on Y. So it will provide me some kind of a reliability that in case of any exigency, if system X falls, I have the data available with me even on system Y. And this is a picture which shows a computer network wherein not many nodes are connected to a server. So whenever there is a communication, telecommunication, you have to have a sender which is going to transmit the message, and there has to be a particular device which is going to act as a receiver to which the message has been sent, and through which the data is sent is known as the media. And yes, the last and the very important thing is that you have to have a message which is being sent, and there has to be a protocol. Protocol is nothing but the set of rules under which the communication between sender and receiver takes place. So herein, this diagram depicts that this is an ATM machine. There is a user at a particular station, one more user at another station. So all these different nodes, they are all being able to communicate through each other. So all these systems will be referred as nodes, and the data transmission will take place through the transmission link. This is the link between these nodes. So going forward in the presentation, we will see that these data transmission media, it can be a guided media or it can be an unguided media. We will be seeing this particular topic in the later part of the session.
Next is the types of telecommunication network. There are many different types of telecommunication network which can be classified on the basis of different factors like area coverage base, functional base, ownership base, and media base. Here is the picture. Types of telecommunication network divided in three parts. Area base covered, it's divided in again three parts. It's a LAN, MAN, and WAN. Functional base, area covered, it's a client server, peer-to-peer, and multi-tier. Ownership base divided in three parts: a public networking, private networking, and virtual private networking. Area covered base classification. Area covered base classification depending on a distance. LAN, it's a local area network, exists within a room, within a building. MAN, it's a metropolitan area network, exists within a metro city, range up to the 40 to 60 kilometer. And WAN, it's a wide area network, exists between two cities and in a geographical range. Local area network. LAN, exists within a room, building, and adjacent building, and maximum goes up to the 5 kilometer. It can be a also known as the sometimes the same campus area network. In a campus area network, it's a large organization have a own campus and own network cable, and through which a department are connected and share the data. It's known as the local area network. In local area network, machines are spread over a small geographical region. Communication channel between the machines are usually privately owned. Channel are relatively high capacity or high speed. Channel are relatively error free. Inexpensive transmission media, inexpensive device, as well as easy physical connection of device to the media. High data transmission rate. It's a local area network. Metropolitan area network. It exists within a metro city. Metropolitan area network is somewhere between a LAN and WAN. An example of a metropolitan area network, it's a cable network that exists within a city. It's a city cable. Example again is a city cable. A metropolitan area network is somewhere between LAN and WAN. MAN are based on fiber optical transmission technology and provide high speed up to 10 Mbps or so, interconnected between sites. A MAN can support both data and voice. Cable television network are example of metropolitan area network that distributed television signal within a city. Next, a WAN is a wide area network that is used to link to different geographical location. It may be within a city, between two cities, and all over the world. Internet has emerged as both the large and the least expensive wide area network in the world, and data transfer speed is up to 1 Mbps, and speed can vary depending on the technology. Wide area network. Internet has emerged as both the largest and least expensive WAN in the world. Data transmission speed, as I explained above, it's up to 1 Mbps, but depending on the technology, it can vary or increase. Features of WAN: multiple user computer connect together. Machines are spread over a wide geographical region and they can transfer information between them. Communication channel between the machines are usually furnished by a third party. Means your cable is your not own cable. In a local area network, we have own network cable, but in a wide area network and metropolitan area network, we can depend on a third party. Channel are relatively error prone because distance are too high, so that lot of error exists in a network. Second, functional based classification. In functional based classification, we have three types of architecture. First one is a client server architecture, second one is the peer-to-peer architecture, and third one is the multi-tier architecture. Client server architecture is the most popular architecture nowadays, in which there's a two dedicated machine exist. One is a client, another machine is a server machine. Peer-to-peer architecture, in which two machines are directly connected to each other, and all the machines are of equal level. But in a client server architecture, there is a dedicated machine known as a server that can hold the data. Client machine request for the data. Server receive the request from the client, and after searching a data in a server database, return to the client. In a multi-tier architecture, there is a different machines, or it's the expansion of the client server architecture. As in a client server architecture, we have a two dedicated machine. Client server architecture suitable for the up to the 100 user. If the user are gone beyond the 100, then we use a multi-tier architecture, in which we use a three-tier architecture. And in three-tier architecture, there's a different layer. It's a presentation layer, it's the application layer, and third one is the database layer. First, we'll cover in detail. It's a client server architecture. In client server, computing power has rapidly become distributed and interconnected throughout the many organizations by network computer system that take the form of client and server network. In client server network, there is a dedicated machine is known as the server, and all the data is stored in a server machine. Number of client machine connected to the server depending on the size of the organization. Client machine always send a request. Server machine always accept the request. According to request, find the data in a server database. If the data available in a server, return back to the client machine. In client server architecture, client and server both are the dedicated machine, and they cannot change the behavior. Means server always provide the service and client always send the data. A client is a single user workstation that provide a presentation service and the appropriate computing. Here in a picture is a dedicated server and here is a client sending a request to the server, and server accept the request and return back the appropriate file or service demanded by the client to the client. A client is a single user workstation that provide a presentation service and the appropriate computing. A client computer can request specific data from the server. The server program retrieves the request data from its database and return it to the client machine. Types of client computer. There are a number of types of client. It's a thin client, fat client, and hybrid client. Thin client. Thin client basically used for the presentation purpose. They're doing a small type of computation, and major part exists on a server. Here is a thin client, and a thin client is here. Presentation part is existing on a client machine, but major part exists on a server machine. It's a data management and application processing all done on a server machine. Means thin client doing a less work. Fat client. In a fat client, presentation and application both are processed at the client machine. and database reside on a server machine. Or we can say if the processing is going approximate 50 or 60% on a client machine, then client is known as the fat client. If the processing is going on at 20 or 30% on a client machine, client is known as the thin client. And combination of these fat and thin client is known as the hybrid client. Server. A server is one or more multi-user processor which share memory, providing computing, connectivity, and the database service and the interface relevant to the business need. A server is one or more multi-user processor with the shared memory providing computing, connectivity, and the database service and the interface relevant to the business needs. Certain machines and devices called the server that are especially dedicated to provide various service to the other computer is called the client. As we explained earlier, a server is a dedicated machine and client always request for a file or data to a server, and server find these files and return back to the client machine. Next architecture is the peer-to-peer architecture. In peer-to-peer architecture, all machines are of equal level. As in a client-server architecture, there is a dedicated machine, it's a server, as well as the dedicated machine is a client. But in peer-to-peer architecture, all machines are of equal level. Machine A can request for the data to machine B. When machine A send a request to machine B, then machine A known as the client, and as the machine B receive a request and return the requested data, at that time machine B treated as a server. And at the same time, second machine, it's a machine number D sending a request to other. So again, sender always or the request machine always known as the client, and service provider machine always known as the server. In another time, it may be possible that machine B is sending a request for a data to machine A, then this machine is treated as a client. And machine A is treated as the server. Both the machine treated as a client as well as the server. In a peer-to-peer architecture, machine treated as a client as well as server. But in a client-server architecture, server is a server and client is a client. They cannot change the behavior. But here, depending on the need, they can change. A peer-to-peer network is created with two or more PC connected together and share resources without going through a separate server computer. In peer-to-peer architecture, there are no dedicated servers. All computers are equal and therefore term as peer. Normally, each of these machines function both as a client as well as the server. Multi-tier architecture. There are three types of architecture. Single-tier architecture. When we are using our machine, our PC, database reside in our PC, and we are a single user access that PC, is known as the single-tier architecture. Second architecture is the two-tier architecture. An example of two-tier architecture is the client-server architecture, in which some part of the database part is always reside on the server machine, and then request part reside on a client machine. And software is also divided in same way. Database part of a software exists on a server machine, and request part of the software is residing on a client machine. Through client machine, we can send a request and server provide the service. As the load increase on a server and number of user increase, then the drawback of a client server architecture is that machine going slow. So that we require a next architecture, that is a three-tier architecture, in which we have a presentation tier, application tier, and data tier. Presentation tier, just sending a request used for the communication purpose. Application tier, hold the application logic and all the application logic solved here. And through application logic, the control is transferred to the data tier server, and then data retrieved from there and returned back to the application tier and then to the customer, and that's a presentation tier. Here is the shown in a figure. Client application, client send a request goes to the Application server, and application server execute application logic and request for the data through a data source. Through data source, we will retrieve the data and return back to application server and then return to the client machine. It's a 3-tier architecture: presentation tier, application tier, and data tier. Next, ownership-based classification. There are 3 types of classification. First one is the public data network. Internet is the best example of a public data network, and everyone can access this type of network. Private data network, it's normally used by the organization. Organization branches situated in different city or different country, but they are connected to each other and transferring a data. Normally, it's the intranet of an organization is known as the private data network. And next one is the virtual private network. Virtual private network is similar. Virtual private network uses a concept of the public data network, and through which we can share the data or information. In a private data network, normally company in a older time have a dedicated cable through which they share a data or transfer a data. But right now, the cost of the private data network is too high, so that they are using a concept of the public data network. They can use a virtual private network as a private network using the public network. Through different sites, they can connect and transferring data. Right now, as a bank, they are expanding their network, and it is impossible for the banking sector to establish own network in all over the country. So they are using a via internet share the information, different branches or different offices of the bank. It's a virtual private network.
Then comes the data transmission. You've just been given some insight that the data transmission takes place within 2 peer-to-peer, or maybe through a client or a server. So when we talk about the transmission of the data, what does this actually mean? The data transmission actually refers to the physical transfer of the data from one system to another. That means the data which was residing initially on system X has been sent to a particular system, say Y. So when we say that there has been a transfer of the data physically, we refer it to be as a data transmission. The data transmission can either be point-to-point or multi-point. So as the name refers, if there are 2 dedicated machines and the data transmission is taking place between these 2 machines, we will call it to be point-to-point, wherein a dedicated line or a dedicated media is available between X and Y. Whereas in multi-point, the data transmission takes place between 2 or more devices. So there are maybe 3 machines, X, Y, and Z, and the data transmission is taking place between these 3 or maybe more. And the multi-point transmission can further be categorized into spatially shared or time-shared line configuration. Now, when we say it is spatially shared, it means that the dedicated link that we have for the transmission, that it is being divided between these many nodes. That means if a line is available, the capacity of that particular channel is divided amongst those many nodes which are sharing the data amongst themselves. Whereas in the time shared line configuration, the same capacity of the channel, it will be divided time wise. That means for a particular duration of time, the data transmission will be taking place between any 2 particular nodes, and the same line will be used for the different nodes, but at a particular point in time, it will be dedicated for the 2 nodes that are sharing the data amongst themselves. So when we say that the data transmission is taking place, so we will refer about the terminology, that is the transmission mode. And the transmission mode can be categorized on the basis of the direction of exchanges, the number of bits sent simultaneously, and on the basis of the synchronization between transmitter and receiver. We will firstly be dealing with the transmission on the basis of the direction of exchanges. So we take here one case that suppose I have 2 nodes X and Y, and the data transmission has to take place between these 2. So when the data is transmitted between X and Y, and if it is only one way, that means if only X is being able to send the data to Y and Y is not being able to communicate back to X, we say that the transmission is unidirectional, that means single way, and this type of transmission is referred as simplex. Herein, if the data transmission is taking place between X and Y but one at a time, that means if X is sending a data at that time, Y has to receive it, and when X is over with the transmission, then Y may send its data to X and then X has to act as a receiver. That means the data transmission though takes place both directions but only one way at a time, then it is referred as half duplex. Like walkie-talkie, wherein one person at a time can speak and other person has to listen. That is the half duplex mode of transmission. And lastly, if the data transmission takes place through both the nodes at the same time, it is simultaneous transmission of the data between X and Y, and we refer as the duplex transmission. For example, the telephone systems, wherein the data transmission can take place simultaneously through X and Y. Now, on the basis of the number of bits which are sent simultaneously, the transmission mode is categorized under two parts, parallel and serial. Now, herein we see when the data transmission is done parallelly, 8 bits are sent through 8 different dedicated channels. So here we see that 8 bits are sent through 8 different wires. The sender has a link with the receiver through 8 different channels, and each bit is being transmitted through a particular dedicated line. That means the data transmission between sender to receiver, all the bits are simultaneously being sent through dedicated lines, and this type of a transmission is generally referred as the parallel transmission. But as you see, it is faster, reason being all the bits are getting transmitted simultaneously, but at the same time it's going to be quite expensive, because to send one byte you need to refer one particular data, you have to have these many number of channels available with you between sender and receiver. Whereas in serial transmission, these 8-bit stream, it is being transmitted from sender to receiver through a common line, and it is done sequentially. That means a sender and receiver are connected through a common dedicated line, one single line, and the data bits are moving in a sequential manner and they are following one to each other. That means herein the data transmission would be slower as compared to parallel mode, but at the same time it's going to be cost effective, because wherein the same data is to be sent in parallel mode, you have to have 8 dedicated lines. Herein a single line is being able to send the data from sender to receiver, though at a slower speed as compared to the parallel mode. Then comes the data transmission mode on the basis of the synchronization between the transmitter and the receiver, and it is further being divided under two parts, synchronous and asynchronous. So herein we see that whenever we talk about the synchronous, as again the name suggests, there has to be some synchronization between the sender and the receiver. That means the data flow is from sender to receiver, and whenever the data bit streams are getting sent, these are all frames of data bits. So when the frames are getting sent from sender to receiver, the sender and receiver, they need their time clock need to be in sync. That means a receiver should be able to know that the sender is sending me the data frames, and at the same time the receiver's clock should also be ready so that the bits are being counted correctly and no data loss happens. Whereas in asynchronous mode, herein you see that there are no time clock syncs between the sender and receiver clocks. That means the frames are getting sent and they are not in continuation. So as and when the sender would be sending the data to the receiver, a sender before sending a data would be sending some kind of a signal in terms of a start bit which is 0. So when receiving 0, receiver will come to know that frames are now about to be received. So the receiver will get active and will receive the data bits. And once those particular frames are being sent completely, a stop bit from the sender will give a signal to the receiver that the data transmission is now over, and then they will again become inactive and there will not be any sync between the two. So herein we see that in synchronous mode, the data transmission is in continuation, whereas in asynchronous mode, there are certain gaps between the units, and that is why there is a need of start and stop bits. And because of these start and stop bits, the transmission is slower and time taking. Then we come about a topic which is the network topologies. But before shifting to the next topic, we would just like to have a look if there are any queries that we have received so far. Okay, as we have not got any query, so we will come back to the session and we will explain the network topologies. The network topology basically is the arrangement of the nodes through which the data transmission can take place. When we say that the nodes are connected to each other so that the transmission happens, then there has to be certain mechanism under which the nodes need to be connected. And that refers to the topologies, or you may also call it to be a geometrical arrangement, that how do we connect different nodes so that the data transmission is effective. Now, which topology is to be used, it depends entirely on this organization for which the network is going to be established. So the famous or the most common network topologies are mesh, star, bus and ring. Now, as the diagram depicts, in the mesh topology, herein I have 4 nodes A, B, C and D, and under mesh topology we will see that all the nodes are connected to each other. That means A is connected to the remaining 3 nodes. Similarly, C is connected to A, B, D, and this way all the nodes are connected to each other. Now, this is the most robust topology because the data transmission between any 2 nodes is going to happen through a dedicated line. So if there is any problem between data transmission on this particular, say, B net transmission media, then only this particular needs to be checked and the troubleshooting will be done for this particular dedicated line only. So that way the data transmission between remaining A, C, B and D will not get affected. Just it would only be the case that the data transmission between A and B through a dedicated line will not happen. And in that particular case, there can be a possibility that the data transmission takes place through C or D. But the major problem with this particular type of topology is that you cannot keep on extending this topology. Reason being, for every particular system, you need, suppose I need to connect n nodes. So for every n node, I need to have n minus 1 by 2 number of links available. Why? Because this particular node has to be connected with the remaining. So if there are going to be, say, 4 nodes, so every particular system has to have 3 links or 3 holes through which these particular lines can be connected, which is a very rare case. And so the mesh topology is limited for limited number of nodes, but yes, it is going to be very, very effective and robust, and troubleshooting is also easier under mesh topology. Talking about the star topology, as the name suggests and the figure also depicts, that here you have a central controller which is known as a hub, and through this hub only whole of the data transmission will take place. Supposedly these are different nodes A, B, C, D, E. If A wants to send any data to C, it will also be done by a server. So the central controller or the hub plays a major role. If this goes or if this fails, whole of the star topology fails. Under bus topology, we see that nodes are all connected through a common dedicated line, and this line again has to be most robust because this is also referred to be as the backbone of the topology, because all the servers or all the particular nodes which are there, they are all going to be connected through this particular backbone. In this particular way, you can keep on adding till the time this particular channel is being able to hold the capacity. It will be easier under bus topology that the systems can be keep on incorporated in this particular topology. Now here in the ring topology, we see that each particular node is connected with two nodes, one on its left and another one on its right. So suppose if A wants to send any data to B, it will be done either clockwise or anti-clockwise. So it may sound to be time consuming, but in this particular way, each particular node has two neighbors, one on its left and one on its right, and depending upon the direction of the data exchange, it will either be clockwise or anti-clockwise. Here, if any system goes wrong, so that system can easily be taken out from the topology, and this system will further be connected to the one next to the defected system, and this way the ring topology will keep on working as there is no central hub. Then the network signals. These can be of two types, analog and digital. And in analog signals, the best example is that they have this sine wave, wherein for a particular range, it may take different values. For example, our human ones. So this particular analog signals, they have this sine wave, wherein for a particular range, different values can be attained. Whereas in digital signal, it can either be 0 or 1, and it is of this square form. And here, this particular 0, 1, for example, on or off. So it cannot have any other value between on or off. It will either be on or off. So it will also here in digital signals, the values will majorly be 0 and 1. Now, you have heard a lot about transmission media, that when we say that there has to be a media for the data transmission, that means they need to be connected. Now, how can they be connected? It can either be through the guided media or through the unguided media. Now, the guided media is actually the cables, wires, or you can also call it to be wired. Guided media can also be referred as wired media, whereas unguided media is referred as wireless media, where the transmission takes place through waves, through satellite transmission. So the best example of guided media is twisted pair, coaxial cables, and optical fibers. Here, the data is through electromagnetic waves, whereas in optical fibers, it is the light waves through which the data transmission takes place. And as the picture shows, herein you have different twisted pair. Like here, from sender to receiver, there are two lines. They both are twisted together. There is one line from X to Y, and there will be another line from Y to X. That means both of the lines responsible for sending the data from X to Y and Y to X, and they are twisted together. So they are referred as twisted pair. Herein we can see that it is in a particular way. Centrally, there is a copper wire and it is insulated. Then the copper mesh, outside insulation. These are the coaxial cables. They are again used for some kilometer. Whereas in optical fibers, they are basically used for the light waves. Unguided media, herein you can see that the data transmission is through the wireless media, and there are no dedicated lines or no cables as such connected. And the data transmission, depending upon the frequency of the waves, it may vary. So radio waves, microwaves, infrared waves, satellite and cellular phones, they all work under the unguided media. They are covered under wireless mode. Each of these waves, they have a particular characteristic which can be read clearly from the study material. Now we have talked about the transmission mode. We have talked about the topologies under which the nodes are connected. Then we did talk about the transmission media. Then comes the transmission techniques. So when we talk about the transmission techniques, what comes in our mind is the broadcast network and the switching techniques. Now, as the name again suggests, broadcast, radio broadcast. The best example is radio broadcast. So when we say about the broadcast network, that means there is a particular node which is sending the signal, and all the devices which are being able to capture that particular signal will receive the message. So herein there is one sender sending the data throughout in an open environment, and all those nodes which have the signal receiving capacity will be able to receive. Like the radio broadcasts its program, and all those people who have the radio system they will be able to receive that particular, if you set your radio system on that particular frequency, you will be able to receive the radio program. So this is the best example of the broadcast networks, wherein the data is being sent not to a particular receiver in general, but it is being sent throughout, and all those who want to receive the data may receive using the proper device. Whereas in the switching techniques, the data transmission is done under these three different ways: circuit switching, message switching, and packet switching. Herein the data transmission is between dedicated nodes, and that is why when the data transmission is done between particular nodes, we will call it to be the switch. We will call it to be covered under switching techniques, and they are again going to be of three types. So we shall firstly be discussing the circuit switching. Now here, as we can see in the circuit switching, suppose we have three nodes ABC, three telephone systems here. The best example is the telephone exchange only, and DEFG, these are the four other nodes through which the data transmission has to take place. Now we can see the diagram carefully. Suppose A wants to send a particular message to G, or there has to be a link between A to G. A wants to speak to G. So these are the temporary connections. These are all switches. On the temporary, in the telephone exchange also this happens, that A is making a connection with a temporary connection with a switch here, which ultimately will be further connected to another switch, which will again be connected to another switch, and this way the switch will be connected to G, and the data transmission will take place through this particular route. It is a temporary connection until the time the data conversation is taking place between A and G. It will be established, and once the conversation is over and the telephone call is cut, this transmission or this connection will also get over. Now the same line, if A wants to speak to E, then this particular same dedicated line can be connected through this way, and the data transmission will take place between A to E. So in this circuit switch network, if each of this particular ABC would have been connected to DEFG, then the number of connections would have been too many. That this A, it would have required 4 lines to be connected with DEFG. So 4 lines for A, 4 lines for B, and 4 lines for C. So this way we would have required 12. Whereas using the circuit switch network and temporary connections, the number of dedicated lines are also lesser, and this way temporary connections are being established and the data transmission takes place between two different nodes. Then comes the packet switching, and it is further being divided in two parts: datagram and virtual circuit. Now the packet switching, herein the data is divided into packets, and each packet will have, that means suppose if this much is the data, then it will be divided among in different packets, and each packet will have certain information. That means it will have an information regarding which number packet is it and from which particular original message it belongs to. So those type of initials will be recorded in packet, and packet will have a certain format which has to be followed depending on a particular protocol under which the transmission is taking place. Now here, as you see in the diagram, packet will have a certain format. As I just told you, it will have a header, body, and footer. So as I told you, that header, it will have an information regarding which particular number. Suppose it's like a pack. This is the data, and it is being divided among 1, 2, 3, 4, 5 packets. So it will contain some kind of an information that what is the length of the packet, which number packet is it, which is the original message, which is the sender who has sent this particular data to, which is the receiver. It will also contain the address of the receiver. So under the datagram approach, as you see here, suppose that A is sending some data to G. So in the datagram approach, if the common data 1, 2, 3 is divided amongst 3 packets 1, 2, 3, there is not fixed dedicated line. Any packet, depending upon the availability, will take different route, So each packet has to have the details regarding the sender and the receiver where it wants to go. So here it will happen that each and every packet, depending on the availability, will take different route, and it may also happen that receiver may receive packet 3, after that it may receive packet 1 followed by 2, and because of the numbering only, receiver should be able to rearrange those particular packets and should be able to get the exact message that the sender initially has sent. So here 2 is taking route A, C, F, G, B is taking A, B, E, G, and 3 is taking A, D, F, and G. So receiver has to have this particular capability to rearrange all the packets. Whereas in virtual circuit, as it shows that if the same transmission, if it has to go via A to G, then it has to be done sequentially. So a dedicated circuit would be firstly established, and then the data transmission through that particular route will happen for all the particular packets. So herein each packet will be followed sequentially. So only first packet needs to know the destination address, as all the packets after that will follow the same route. And so the receiver will also receive all the packets sequentially. So rearrangement of the packets is not a question in virtual circuit. In message switching is also known as store and forward. What is happening here is, suppose the data A is to be sent to A machine is sending some data to Q. So what will happen that if the data is transmitted through SP1 through this B to Q, then what will happen that store and forward means a particular node in between will store the data temporarily in its storage, and when an appropriate route would be available, it will further be sending that particular data forward. So there is going to be some kind of a storage in the intermediate nodes, and depending again on the availability of the route, it will further be forwarded so that it reaches to the destination. So this is a major way that the data is not followed in a particular path, rather it is being stored temporarily for some time, and then on the availability of the route, it is further being forwarded so that it reaches to the destination. So it's also referred as store and forward. Now we've been talking a lot about transmission protocols, and we've also been saying that whenever the data transmission has to take place, it has to follow certain set of rules that would govern the data communication between two parties, the sender and the receiver. So any data transmission protocol will have three characteristics: syntax, semantics, and timings. Now syntax refers to the structure or format of the data. That means it refers to the order in which they are presented. The semantics refers to the meaning of each section of bit, and the timing, it refers to two characteristics: when the data is to be transmitted and how fast can it be transmitted. So any transmission protocol will have these three features. The first protocol reference model that came into picture is the OSI reference model, and herein we see that it is also referred as layered model, wherein depending on the working, it is being divided in 7 layers: level 7, 6, 5, 4, 3, 2, 1. The sequence is very important, and so one has to learn it. So the application layer is the layer which is closest to the user, and physical layer is the layer which is actually the hardware part, from where the cable is connected and the data transmission actually takes place. Now before any data is to be transmitted, it will go through under these layers, and some kind of logic will be applied at each and every layer. So level 7, 6, 5, 4, 3, 2, 1, when the data would be passing through these layers, something will get added, or maybe something will get divided into different frames and packets, so that the data at this end will be converted into 0 and 1, and the data transmission takes place through the guided media or the unguided media. And at the receiver end, it will again be done other way around, so that the other user will get the exact information or the message that the sender machine has sent to. Herein, we see that layer 7, 6 and 5, they are software based, whereas level 4, 3, 2, they are hardware and software based. The routers and the hubs, the switches, they will all fall under this particular way. And layer 1 is lastly the hardware based, wherein I have just spoken that it will be related to the transmission media. So now we shall see that host A and host B, suppose the data transmission is taking place between these two nodes. So each layer will have certain role to play in. So we will just see what happens that when we talk about the application layer, this is the layer which is closest to the end user. And this layer basically provides a platform to the user to interact. That means any data which is to be sent, you have to have a platform through which you will be sending your data. Suppose you have to send an email. So the application layer is basically responsible to have your system open up with the mail ID of yours so that you can reach to that particular platform wherein you can send your message to a particular recipient. When you send a send button, you press a send button, then that particular data is to be received by host B. So the data would go to the presentation layer, and the presentation layer basically deals with the syntax and semantics of the data transmission. That means herein the data will be converted into a meaningful manner so that it can further be descended to the session layer and the data can actually be converted into the proper format through which the data transmission may take place. Then that particular data would further be passed to the session layer, and session layer basically is also known as network dialog controller that establishes, maintains and synchronizes the interaction between the communicating parties. Then the transport layer is also known as source to destination layer, wherein the transport layer is actually responsible for the exact transmission of data from the sender to the actual receiver. The data before getting received at the receiver will be passing through different nodes, the intermediate nodes, switches and routers, but transport layer is basically responsible for the exact or actual communication or the transmission of the data between the sender and not only the intermediate nodes, but it ensures that the data in its toto is received by the recipient, the desired receiver. Then comes the network layer. Herein the data, now the transport layer, the data would be divided among segments. Those segments would further be broken down into packets, and as I have told you, the routing part, the switching part, it mainly happens in the network layer. When a data from a particular network crosses that network and goes for the different network, then the network layer will come into picture, deciding for the best route available, which particular switching technique to be used. The network layer would basically be deciding that, and here the data would be in form of packets. Now when the data is flown down, it will come to the data link layer, wherein the data packets would further be broken down into frames, and here the data link layer will be responsible for any error transmission. Error correction has to be taken place at data link layer. Any transmission that has lost, it has to be retrieved again. It is also done at the data link layer. So basically the data transmission errors, any congestion control, all that has to be taken care at the data link layer. And once the frames are being made, the data is given to the physical layer where they are being actually broken down into bits 0 and 1, and through the physical media the data transmission will take place. Here the synchronous and the asynchronous mode, the simplex, half duplex, all those transmission modes which we have just read, they will all come into picture, the guided media or the unguided media through which the transmission actually has to take place. It will happen and it will pass through different switches or routers to reach to the recipient. And once the receiver will be receiving the data, it will receive the bits. So the bits has to be combined into frames, packets, segments, and this way ultimately each layer correspondingly will be working, and end of the day host B has to receive the data in the format in which it was sent to. So here we say that any particular layer at the sender end will actually be communicating with three parties, the one just above it, the one below it, and the one corresponding layer on the other machine. So TCP/IP, transmission control protocol and internet protocol, it is the most widely used protocol. And here the OSI model is actually a model which gives us a brief idea about how the transmission has to take place. But practically TCP/IP, if you see in some books the layers are given 4 layers, but actually if you will see, it will be one way that all the tasks that is being mentioned at the OSI model, they are being taken care at TCP/IP. So application layer, presentation layer and session layer, these 3 are combined in the application layer at TCP/IP because they are the software based. Then the transport layer is almost the same, network layer, data link layer and physical layer. In some of the books you may find only 4 layers here, but functioning will entirely be the same as suggested by the OSI model.
Our next part is the network security. Now, network security can be done through the 4 ways. One is the privacy, message authentication, message integrity, and non-reputation. When we are sending a message on an internet or network, number of users increasing day by day, so we require a security. If we are sending a message from one mail ID to another mail ID, then there may be possibility of hacking, so that we can send data with some coding system, and this concept is known as the privacy or confidentiality. In privacy concept, before sending a message, a software can convert a data in a coded form, and this conversion is called as the encryption. And then encrypted data will send via the channel and then received by the receiver. At the receiver end, this encrypted code is decoded, and this concept is known as the decryption. Now, combination of encryption and decryption is known as the cryptography. Here in the figure, if a sender send a data, it's a plain text here, uses some key, it's an encryption key is here, and then this is an encryption method implemented here, and the text is converted into a coded form, and this text is known as the ciphertext. This ciphertext is sent further and then received at the receiving end. At the receiver end, the software decoded this ciphertext, and this concept is known as the decryption. Here is the decryption method. Again, using the key, this is some method by which we can use the encryption and decryption, and finally at the receiver end we get the plain text. So by which we can send the data. Secured mode is called the privacy, and concept is known as the encryption and decryption. This concept frequently used in a digital signature. Next is the authentication. Sender send a message. Who's the sender? If you want to confirm it who's the sender, then authentication is activated. This means that the receiver is sure of the sender identity, and that an imposter has not sent the message. भेजने वाला कौन है मुझे पता चलना चाहिए. Who's the sender? और किसने इस मैसेज को सेंड किया है, इसलिए मुझे सेंडर की आइडेंटिटी चाहिए. This concept is known as the authentication. Next is the integrity. If sender A send a message to the sender B, if the message is interrupted in the air or in the line or in a wire, and accessed by the third party or altered by the third party, is called the integrity lost. Here is the integrity. Integrity means message as the message sent by the sender, same message received at the end of the receiver, and interruption in the middle or in a air or in a wire is not happened. This means that the data must be arrived at the receiver exactly as it was sent. There must not be any changes during the transmission, either accidental or malicious. Here is an example. Now Alice is sending a message to Bob. Is Bob receiving exactly the Alice is sending? तो वैसा ही मैसेज मिला है जैसा कि भेजा गया था. दैट्स अ इंटीग्रिटी मेंटेन है, और अगर बीच में इंटरप्शन हुआ है, उसमें ऑल्टरेशन हो गया, इंटीग्रिटी लॉस्ट हो गया. तो सेकंड वे इज द मैसेज इंटीग्रिटी. थर्ड वन इज द नॉन रेपुटेशन. If a message received by the receiver and after receiving a message, sender denied that this message does not send by the me, then this concept is known as the non-reputation. This means that a receiver must able to prove that a received message came from a specific sender, and the sender must not be able to deny the sending it. तो बिल्कुल भी मना नहीं कर सकता है जिसने भेजा है, कुछ मेथड हो कि पता चले उसने वो मैसेज भेजा था और उसको डिनाई ना कर सके. दिस कॉन्सेप्ट इज नोन एज द नॉन रेपुटेशन. एज इन अ फिगर शोन, नॉन रेपुटेशन इज व्हेन अ यूजर सेंड अ मैसेज and later refuse he or she had sent the message. I never sent you message, so it's not possible. So this concept is known as a non-reputation. Non-reputation does not allow the sender of a message or refute the claim of not sending that message. Network security. Day by day, use of network is going to be increased in our life. And we are sending a data or receiving a data, or dependency on a network increasing in a day-to-day life regularly. So that we required some kind of security. Here is the some system. First one is the intrusion detection system. Second is the firewall. Third one is the network access control. Next is the anti-malware and site blocking concept. First is the intrusion detection system. Now these are the some kind of the hardware and software, or installing on a system or on a network. In a network intrusion detection system, this is the software we can install on a network, and this network intrusion detection system detect the illegal behavior, malicious behavior on the network. If it is happened, it detect and send to the administrator or management there is something adverse happening on a network. That is known as the intrusion detection system. The intrusion detection system is divided into three parts. It's a network intrusion detection system. As I told, the network intrusion detection system is a place somewhere on a network, and it will detect the malicious activities. It's a virus is coming on a network, something else, and send a message to the administrator or management. Second option is a host-based intrusion detection system. This will install on a system or host machine, and as the user access the system without permission, then again it will send a message to the administrator. Okay, this is the access the system by without permission, or you can change the policy. Security policy is altered. Everything is message sent to the management. And combination of network and host-based intrusion detection system is a hybrid intrusion detection system. Next one is a firewall. Now, when we are using a net, there is some data or illegal programs come through the network, and this we can restrict using the firewall. As shown in a figure, here is the green line shows that the data is accurate. With this green line, here is some red data is shown. That's some illegal function or program or virus are there. As the data passes through the firewall, it will detect the logic of this particular program and restrict it, and the exact data pass it to the machine or server. Firewall is a device that form a barrier between a secured and open environment when the latter environment is usually considered hostile, for example, the internet. As we know, most of the virus come through the internet. So on a system, we should activate our firewall through which we can reduce the attack of virus. Network access control. This concept is used to providing a policy or security policy. Network access control enforce security policy by granting only security policy compliance device access to the network assets. Only the permitted user can access the device as well as the software. No one can access without any. It's a network access control. Anti-malware. Malware short for the malicious software in any software used to disrupt computer operation, gather sensitive information, or gain access to a private computer system. We can install an anti-malware software. They can interrupt all the illegal type of software, malicious activity. All these are detected and identified and removed from the network or system. Next one is the site blocking. This concept is installed by the organization through which we import some control on our internet or some networking devices. User cannot access all the sites, only the management site can be accessed. That's it, and all the sites are blocked. Similar, normally employee can access a YouTube or etc. sites on an office. If this type of activities happen, then we go for the option is a site blocking. Site blocking done through the proxy server or etc. different method.
So to summarize the session today's on telecommunication and network, we have dealt with the definition of the computer networks, what do we mean by telecommunication network and what are the components that are required, and then the different transmission modes depending on the basis of the direction of exchanges, the number of bits that are being sent simultaneously. We have categorized them and we have discussed them at large. Then we had spoken about the network topologies, the mesh, star, bus, ring topologies, the transmission media, which we have just seen that it could be either the wired media or the wireless media. Then the switching techniques. We had talked about OSI and TCP/IP in detail, the different layers, and Sir just explained you about the different security mechanisms that we may have in a computer network. So this way we have understood the basic concepts regarding the computer network, and anything that is being prevalent in the study material that has all been discussed. So the students are suggested to read the chapter in detail, and they will be able to recapitulate a lot of many concepts that have been discussed, and those who had already studied the chapter, they would have found this particular session of ours on transmission network of some use, as it gives the complete brief overview about the different topics that are there in the chapter 3. Then now going to the next topic, which is not as such relevant to the telecommunication network, but is a pain area for lot many students, is a flowchart. So what exactly is a flowchart, and what all do we need to take care in when we are preparing a flowchart in the examination or when we are preparing for it? Then the flowchart is basically a pictorial representation. It gives me a picture of what all things are going to happen in a particular process. And when we are saying that it has to have it's a pictorial representation, then there are certain norms or certain symbols that we need to refer to while drawing a flowchart, because each particular symbol will have its own significance, and that symbol itself will be telling a lot to me that whether it's a process or it's a question or it's some input or it's an output. So depending upon the different symbols that we have here in flowchart and where do we use it, that particular information itself will be sufficient just having a look at the document symbols. So flowchart is being used at large by lot many architects and lot many system analysts, because whole of the process, what all is it about, writing in documents, writing it in textual form will not make much of an understanding. At the same time, if the pictorial representation of the same process is drawn, it is more understandable and it does make sense. So the flowchart is basically illustrating graphically the steps of a process or a structure, and it majorly is used for training, troubleshooting, testing and inspecting the process. So it is advisable that whenever there is a documentation part which is prepared, if any software is prepared, it is being advisable that for every process one should also make a flowchart correspondingly, so that what all information that is being given in a textual form, it is also depicted at the same time through the pictures. So When we say that we have to have a flowchart, I've already explained that we have to have certain symbols, we have to have certain norms. So this particular slide of flowcharts give us a brief idea about what all majorly used process symbols are, though there are many, but majorly used symbols are the process symbol. That means any processing, any functioning or any action, if it's to be taken, it has to be shown in this rectangular form process symbol. Then this is the document symbol, the second one. If we have to show that any output is taken in a hard copy or input is given through a hard copy, then this type of a symbol is used. Decision symbol, wherein we have to have yes or no answer. So it will have two branches. Not many students make this type of a mistake that they give only one branch, they do not cover the no part or the yes part. Then start and end symbol, it gives us a message that herein the process starts and herein the process ends. And any input output symbol which is being given in the computerized form, it is here as a parallelogram. Sorry. Now we shall see one example of a flowchart and we will see how it can be worked on. A housing society in a newly developed smart city has provided several advanced security systems to each house in that city. Based on the value of these advanced security systems installed in each house, the society has divided all the houses in 4 categories and fixed the criteria for annual maintenance charges as under. So the house categories are A, B, C and D, and the maintenance charges are with respect to the category of the house. The maintenance charges are 8%, 6%, 4% and 3% respectively. At the same time, there is a service tax at the rate 12.36% on the amount of maintenance charges. This is going to be applicable for all the house categories, but the maintenance charges vary with respect to the category of the house. Considering house number and value of advanced security system installed as input. So you've been given the input that you have to give input as house number and the value of advanced security systems installed. Draw flowchart to have printed output as house number. What all do we need to get at the end of the process is house number, maintenance charges, service tax and the total amount to be paid by each house owner. So here is a snapshot of the problem. So we firstly need to define the variables that whichever program is there, whichever problem is there, I need to solve it. And when I need to solve it, I have to have certain variables wherein I will be storing the information or the input or will be giving the output temporarily. So I need to define the variables first. So house number, house category, value, VAL_ASS, this shows the value of advanced security systems. Now, one question could be that how do I come to know what all variables I need to take? So obviously the input that is being given there, I need to have that as variables. Then the output, all that output that I need to print, that also I need to have as variables. And intermediate calculations, if any variable I need to store for that particular intermediate calculation, I need to define that variable also. Things will be more clear with the help of this diagram. So as I had already mentioned that this oval is for start, so you can see that start and stop symbols, they are showing me that the flowchart has just begun. So start symbol here. So as it's being already given that the number, house number and value of house number and value of advanced security system installed is an input. So I will take these two as input. House number is denoted as HNO and the value of advanced security system installed is being shown as VAL_ASS as defined in my variables. So we will firstly be getting this particular information and we will see if the house category is of type A or not. If the house category is of type A, then this is the decision box, and as I already told you that it has to have two branches out of it, yes and no. So it's a question. If it is true, then I need to go this way. If it is no, then I will go on the other side. So if house category is A, then it's been clearly shown that it is the maintenance charges 8%. So 8% of the value of the advanced security system installed. So I calculated 8%, which is 0.08 into VL underscore ASS. But if the category is not A, then no part, then we are going to check it for category B. If the house category is B, yes, then correspondingly 6% calculation. So we will do the calculation here. If it is yes, if it is no, then we will again check it for C. And if it is yes, then house category C, the maintenance charges are 4%, so it becomes 0.04 into val underscore ASS. And here we will not be checking it for D. Reason being, if it is not falling in A, B, C, then we at any point in time, considering it to be a valid input, will understand that if the house category is not falling under A, B, C, then it has to be house category D only. And so by default, the maintenance charges need to be 0.03 as corresponding for D house category into val underscore ASS. So for all this, we have till here we have calculated the maintenance charges, what all need to be calculated. So herein we have calculated maintenance charges, but then the total amount has to be paid once the service tax is also included. And service tax is flat for all the house categories. So whatever maintenance charges have come out to be here, it will fall with 0.1236 into MC category, and this way we will be able to calculate the service tax. And the final amount that one needs to pay, total amount, will be the MC plus ST. Why are we showing MC independently? Because it is being asked from us to display the maintenance charges also. Most of the time it does not happen. Most of the questions, they simply ask for the total amount that needs to be paid. So in that particular case, we would have written maintenance charges here. We would have got it printed as house number, ST and TA. And then obviously if there are any further more house numbers, then this process has to be completed for all the house numbers that are there till the time house numbers are all exhausted and there is no further entry. So when there will be no further entry, it will be a stop. And if it will be a yes, that yes, some more input or some more house number are available, then it will go on to yes, and the process will altogether start from scratch, reading the house number and value of the advanced security system installed. So herein we have to see what all inputs are being provided to us and what all needs to be calculated. And then we need to work on the interior or the internal processing that needs to take place. Some might not calculate maintenance charges at all, might have calculated directly here. But then because maintenance charges are to be printed, so we need to refer to maintenance charges, and this way we will be able to calculate the flowchart. So this is one example within which we have tried to show that flowcharts, how can flowcharts be drawn. So we need to understand what all is being given to us, what all is going to be an input, how the processing will lead to the desired output. Accordingly, we need to define the variables first, and some of the carefulness is to be brought in when we are using the symbols, that which particular symbol, like in here input has to be in a parallelogram, so we have shown it here. So that way we have to be careful enough to show which all symbols we are using, and because each symbol has its own significance. So with this we are through with our presentation, and we would there is one question and we would like to give an answer of the same.
The decryption message, can third party read out the message? Reading is not possible.
See, decryption method, can third party read our message? Is it secure? The third party generally intervenes when the transmission between the sender and the receiver is taken place. So at the sender end, the encryption is done. The decryption is done at the receiver end only. So any third party will intervene during the transmission only. It cannot happen at the receiver end because the desired message has to be received by the receiver only. So if there will any be third party, the third party will be involved during the transmission of the data only. When the receiver has received the data, it is the authenticated receiver only. So the question in itself, the decryption method, can third party read our message? It cannot be the case. It can intrude our message, but by and large, because if it's being used combination of public and private key both, then this type of decryption breaking is also not very viable. So generally, by and large, it is considered to be quite a lot secure and safe. And with this, we hope that today's presentation on telecommunication networks and flowcharts is of some importance to you. As and when you would be going through or progressing with your subject, if you will find any kind of an issue, you may directly send your email to me at sukriti.arora@ica.in. sukriti.arora@ica.in. So any kind of a query, if you will have, you may send your queries to me, and within 5 to 7 working days, we'll be trying our best to give you the reply. And all the very best for your preparation. Just try to concentrate on the topic. The topics are though technical, but not very, very tough, as if they'll not be, you'll not be able to understand. Should just try to give some time to yourself and to the subject also. And it's the best methodology that you cover and study the subject each day for some time. Do not leave the subject for the last time, that once you finish off with your other subjects, then probably you'll start up with IT. IT is one subject you have to be in touch with every day. All the very best and do your best. Thank you.